So now we're going to talk about truth tables. So we're going to talk about truth tables and how we can construct tables in order to evaluate either arguments or propositions to see whether or not the entire proposition is true or false based on different values that we can have from the different variables. So who remembers what the definition of a proposition is? What's a proposition? Very good. It's an assertion that can be true or false. Assertion that can be true or false. In other words, when you have a proposition, P, there are two different outcomes that you can have. It's either true or false. That's all it is, right? So you can have the value of your proposition be true or false. Now, remember we talked about the different compound propositions, right? The first one is the negation. So, not P. So if we have the compound propositions, the negation will be not P, or tilde P, right? So, the negation of P, when P is true, what do you think is going to be? False. If I say P is true, then the negation is going to be false. If P is false, what's the negation going to be? True. True. Very good. So the negation, the rule of the negation is it always has the opposite truth value. So with the negation, we only have one variable. So we have one variable with two outcomes. So the way we express it is 2 to the power of 1. So we have two different outcomes, true or false. If we have more than one variable, if we have two variables, then it will be 2 to the power of 2. So there will be 4 different combinations that we can have of the truth values. So let's look at our different ones. For example, if we look at conjunction, and conjunction is what? And. So if we have and, we will have, for example, P and Q. Now remember, if you want to express conjunction, and isn't the only way. You can express it with but, however, although. Those are all different ways of expressing a conjunction. So if you want to express a conjunction P and Q, you're going to have two variables. You're going to have P and you're going to have Q. And like I said, there's going to be 4 different combinations that you can have of these two variables. The way that you start out a truth table, on the far left, you're going to put 2 truths and 2 falses. And then under Q, you're going to alternate true, false, true, false. This only assures that you're going to have every combination of these variables. In other words, you're going to consider the value if both your variables are true. If the first one is true, the second one's false. First one is false, second one's true, or both of them are false. Those are the only combinations you can have. So, if we consider P and Q, we're going to look at the rule of the conjunction. The rule of the conjunction says it is only true if both variables are true. Otherwise, it's going to be false. It is only true if both variables are true. Think about it. If you say, for example, today is raining, and you say, today is Friday. If you say, today is Friday and it's raining, it's going to be true because it happens to be Friday and it happens to be raining. But if I told you today is Thursday and it's raining, even though part of it is true, but the whole sentence is not true. The conjunction isn't true because part of it isn't true. Do you understand? So a conjunction is true when both of the conjuncts, remember P and Q are each called a conjunct. So it's only true if both conjuncts are true. That's how a conjunction is true. So in which row is it that both conjuncts are true?
First row.
In the first one. So here it's going to be true, otherwise it's going to be false. The point is to fill out the entire truth table. Okay? So the next one is the rule of the disjunction. Now, the disjunction is either or, as we have discussed, and it's P or Q. And each of them are called disjuncts, remember? So, a disjunction is true always, unless both of them are false. Remember the rule of logical addition that we talked about? You can add anything to a statement, so long as one of them is true, then both are going to be true, right? So if I tell you, for example, either it is Friday today, or we're all taking the magic carpet home tonight. We can say either or. So long as one of the disjuncts is true, that entire disjunction is true. Because I didn't say and, I said either or. So if part of it is true, the whole thing is going to be true. So the only time that a disjunction is false is if both the disjuncts are false. So it's only false if both disjuncts are false. And here too we'll make it conjuncts because it could be more than one. So both conjuncts are true. So a disjunction, so we have a negation, we have a conjunction, and disjunction. The disjunction is either or. It is only false if both disjuncts are false. So if we have P or Q here in a table, where is it going to be false? Only at the bottom one, right? So otherwise, it's going to be true. Now we have the rule of the conditional. The conditional, which is an if-then, if P, then Q. P is our antecedent, Q is our consequent. The rule of the conditional says it is only false if a true antecedent leads to a false consequent. That's the only way it's false. Otherwise, it's going to be true. True goes to true, it's true. False to false, it's true. False to true, it's true. But true to false makes it false. So, it is only false if true antecedent leads to false consequent. So it is only false if a true antecedent leads to a false consequent. So if P then Q, where is it going to be false? In the second line, because true antecedent leads to a false consequent. So here it's going to be false, otherwise it's going to be true.
So a false antecedent can lead to a true consequence?
And it's fine. And that would be true. But if true goes to false, that's going to be false. And the last rule is the rule of the biconditional. The biconditional, which is the if and only if. P, if and only if. So, with the rule of the biconditional, because see the arrows are going both ways, so both of the values have to be the same for it to be true. It can be both true, it can be both false. It has to both be the same for it to be true. So, the rule of the biconditional says, only true if both values are the same. So where is it the same here?
1 and 4.
Very good. So it's going to be true here, it's going to be true here. Otherwise, it's going to be false. And that is the rule of the biconditional. Now notice, we only have 5 rules. We only have 5 rules. Negation, conjunction, disjunction, conditional, and biconditional. So you have to know these rules enough so that you can not only be able to do the operations inside the truth table, but once we have them in our shortcut method, which I'll explain in a bit, you're going to be able to apply it very well, all these rules. Okay? So 5 rules. As I've told you before, it's important that you understand them first, then memorize them. Otherwise, if you just memorize them, you're going to lose it just as easily as you got it. So understand what it means. Why is it that both conjuncts have to be true for it to be true? First, get that. Let that settle in your mind, and then you can memorize it and, of course, move on. Okay, any questions on this part? The rules, yes?
Can you explain the disjunction?
Yes, of course. The disjunction is either or. The disjunction says the only time that I give you an either or statement, if both of what I'm saying is false, then the whole thing that I'm telling you is false. If I tell you either we're all wearing hats today or we're all flying home today, then it's going to be false because both sides are false. Both disjuncts are false. But if I tell you something that's false, but I pair it up with something that's true, if I tell you, either we're sitting in class today, or or we're in Hawaii right now, then because the sitting in class part is true, the whole thing is going to be true. So as long as both of them are not false, it's going to be true. Which is why you see here, it was only false down here when both of them were false. Otherwise, it was true. Any other questions on this part? Okay, so another thing that we have to really understand in order to move on with the truth tables is the main connector. So we have these connectors, but sometimes they're grouped together in bigger propositions. So if you have a negation, for example, you have the negation of P right attached to it, you know that you're going to perform that negation. If P is true, negation is going to be false. If P is false, negation is going to be true. What if you have, if P then Q, and then the negation is outside of the parentheses? Then what you have to do is, you have to first perform the operation that's inside the parentheses. Then you negate that. You negate this value is negated. Not P, but the value inside the parentheses. So first you do what negation is attached. Then you do what's inside the parentheses. Then you do what's inside the bracket. Then, of course, outside the squiggly. So it moves like that. So let me give you a couple of examples for you to identify the main connector. So if I tell you, if P then Q, or not P and Q, what's the main connective here? What's the main connective here?
Or.
Very good. It's or. So basically what this is telling you is take P, negate it. Then do the operation of conjunction with Q. Take P and do the operation with Q of condition. Then take those answers and do the operation of or. So that's the main connective is the last operation that you do.
Can you do the truth table?
Yes, I'm gonna do your truth table right now. But it's very important for you to be able to identify the main connector. So one more example so you can do it. So what if I say P and Q or R? You see how this doesn't make any sense, right? So I have to pair it like this. Once I have the parentheses, then I know that what's inside the parentheses is done first, and then the operation outside it. So what's the main connective here? Or. What about if I do this? What's the main connective now?
Not.
It's the negation. Very good. So it says do something inside the parentheses, then do this operation with R, and then negate the whole. So understand, please, the concept of the main connective, and then we can move from there. Okay. So let's do a truth table for a proposition. So there's different ways that we use a truth table. One is just to be able to find the value of a proposition. So say you're given a proposition, and then you're asked to do a truth table. You construct a truth table. So you're giving pretty much all of the different combinations of the variables to tell us what it's going to be. Is the proposition going to be true or false based on the different values that you have? So let me see if I have an example for you here. So let's do this one. Let's have the proposition not P and Q, then P if and only if Q. given this proposition and we are asked to construct a truth table, a complete truth table for this proposition. So because we have two variables, we're only going to have P and Q. So we're going to start exactly as I told you here. This is the format that you begin. And this way, everyone's doing the same truth table. So you're going to do true, true, false, false, and true, false, true, false. Now in each row, the variables are going to have the same value. So if you, wherever you see P and you see Q, you're going to have the same exact values. So you pretty much take over the values here. So anytime I see P, I'm going to put true, true, false, false. Anytime I see Q, it's going to be true, false, true, false. Okay? So basically, I just moved over the values inside the table. Now, what is my main connected?
Negation.
The negation outside. So this is the last thing I'm going to do. The main connected is the last operation that I'm going to do. What is, now I can work inside the parentheses, right? So what is the rule of the conjunction? When is it going to be true? It's only true if what?
If
both
both
conjunctions
conjunctions
are
are true.
Very good. So where is it true?
First one.
Very good. Otherwise, it's going to be false. So the goal is to fill in all the truth table here. What's the rule of the biconditional?
Only false if true antecedent needs to.
No. This is a biconditional.
Oh,
So biconditional is true if both values are
the same.
the same. Where are they the same?
First and the last.
Very good. So here it's true, here it's true. Otherwise, it's false. Now, which operation do I do? The conditional, right? So if I want to do the conditional, I'm going to look at the value that I had here and the value that I had here. I'm not going to look at anything else because I've already done an operation. So if I look at this, what's the rule of the conditional? It's only false if, very good, if true goes to false. So here we have true going to true. So what is that? True. False to false? True. It's only true if we have true to false. That's the only way it's going to be false. Otherwise, it's going to be true. False to false?
True.
False to true?
True.
Okay. So does everybody get this?
What is-
I looked at this column, I looked at this column, and I looked at this column with the green dots.
So we're just looking at the middle.
That's right.
Okay.
Because we already did the operation.
Yeah.
So now, but the only way it would be false is if it went from true to false. But we don't have a true to false. It's all true. So now what operation do I do?
Negation.
Negation, very good. So what is the negation of true going to be?
False.
So false, 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 false.
So when we're looking at negation, we're looking at the middle, the conditional what we did.
Yes. We're looking at the last operation we did inside of our bracket. We're negating that. Yes.
What is the purpose of this whole table?
The purpose of the table is to demonstrate to you every different combination of values and every truth value that you're going to get by applying this to. So basically, by looking at this table, I've told you, and then you have to box your main connector. I've told you, listen, this proposition is always going to be false, no matter what value you plug into P. That's what it's telling. And because it's always false, it's a contradictory. A contradiction or a contradictory is when all the values are false. Are false. A tautology is when all the values are true. And a contingency, which in most cases we have contingencies, is if some values are true and some are false. So in this case we have a contradictory, because no matter what I plug in, I'm always going to have a false inside this. Yes,
Can you
ma'am.
explain the second row, when if it's true, then if it's true, false, false, then we're getting truth because antecedent was true?
This one,
No, yeah, that one.
second. So this was false,
Yeah.
right? And this was false.
Yes, and false, false, it gives true.
Yes.
Okay.
The only way it's false is true.
Oh, okay.
We're
You're
looking
on a
at
middle
the,
ground.
this
Okay,
one.
yeah.
Any other questions? Okay, so I'm gonna give you another example of this, and then I'll do one with 3 variables, just so you see. Is everybody okay with me erasing it? Okay. So let's look at this one. P or not Q, then Q and P. So, everybody, help me do this. How do I start a truth table? Very good. P and Q, and what are the values I assign? Very good. Excellent. Next thing is what I do.
Main connected.
Well, I first spread the values so that I know exactly what I have here. So everywhere I have the values, I'm going to spread it out. Okay? Now, in this parenthesis, what do I have to do first?
Or.
The negation. Remember, you always do the negation that's attached to the variable first, and then, because this is not saying P and Q, P or Q. This is saying P or not Q. So that's the value I'm going to consider. So what is not Q going to be here? False. Here? True. It's just the opposite. The rule of the negation is the opposite truth value. So now I'm going to look at the value of P, but the value of not Q. I'm not going to look at the value of Q. I already negated. So when is a disjunction going to be false? When both are false. So where are these both false?
Right there.
So here it's going to be false, otherwise it's going to be true. Now, the rule of the conjunction is it's true unless, it's only true if both are true. Where is it both true? So it's only true here. Now, I look at the value inside the parenthesis that I had, the disjunction and the conjunction, and apply the rule of the conditional, which says it's only false if what goes to what?
True goes to false.
True goes to false, excellent. So here I have true to true, that's true. True to false, that's false. False to false, true. True to false. The last thing I do is I box my main connector. By boxing it, basically, I'm telling you, when the value of P is true and Q is true, this entire proposition is true. When the value of P is true, Q is false, this entire proposition is false, and so on. This is what I'm telling you. Sam?
So you use that outermost, what would you call it, the arrow right there?
Connective.
The connective to determine if P and Q are true or false.
That's right. Basically, it's saying the last connective is determining the truth or falsity of the entire proposition.
Right.
Exactly. Very good. Yes?
What happens when you have 3 variables?
Okay, so this is what we're going to do now. 3 variables. So if we have 3 variables, it's 2 to the power of 3, right? So it's going to be 8 lines. So if we have 3 variables, let's say we have, let me see if I have, okay, let's say we have P, Q, and R. And let's say our proposition is P, if and only if, not Q and R. Okay, let's say that's our proposition. So, if we have 3 variables, in order to see all of the different combinations, we are going to have 8 lines. And the way we start on the far left, instead of having 2 truths and 2 falses, we're going to start P with 4 truths and 4 falses. It's not any more complex, it's just mechanically more work. Otherwise, the rules are exactly the same. So you put 4 truths, 4 falses. For Q, you're going to put 2 and 2, 2 truths, true falses. And then R, always the far right, you're going to alternate. It's going to be true, false, true, false, true, false, true, false. So that's a standard way of doing it to ensure that you're going to have every possible combination. So with 3 variables, these are the only combinations we can have. And remember, the truth table is the entire combination of values. So then I go proceed just like I did before. I fill it out. So everywhere I see P, I have 4 T's and 4 F's. Everywhere I see Q, I'm going to have 2 and 2. And everywhere I have R, I'm going to alternate.
That's it?
Yes,
So that's always the first thing you do after you've filled out
yes,
those.
yes. Standard, you fill in, assign the values, disperse the values. You have the skeleton and then you do the operation.
Exactly. Yeah.
So now I have a negation attached to the Q. So what is that line going to read?
Opposite?
Yes, false, false, true, true, false, false, true, true. Now, for the conjunction, conjunction says it is true only if both values are true. So here I have false, here I have false, here I have both of them true. So this is true. Here I don't, here I don't, here I don't, here I have both of them true, and here I don't. So otherwise it's going to be false. It is only true if both of them are true.
So in that one, we're looking at R and the negation.
That's right. You always, when you perform a negation, which is attached to the variable, you look at the negated value when you're doing the operation. Because this is not telling you Q and R. It's a not Q and R. There's a difference.
But if the negation's not there, then you're looking at Q and R.
Yes. Okay. Yes. Now, the rule of the biconditional says it is true if both values are
True. False.
the same. The same. So here we have true and we have, now remember, these are the values we're looking at. We're looking at P and we're looking at the last operation we did inside the parentheses. So here we have true and false. True going to false. What is that?
False.
Very good. True to false.
False.
Both have to be the same. So this is both the same. True, false, different. False, false. That's good. False, false. False, true. False, false. Sorry. Okay? So we have, when we have both variables being the same, it's going to be true. Otherwise, it's going to be false. So we're done with it. What do we have to do with the main connected? Box it. Very good. So we box it, and that's it. So it's just the same as having 2 variables, but it's just more lines. So mechanically, it's more work.
So does that mean that it's like contingencies is?
Yes, very good. This is a contingency because there's some true and some falses. So with 3 variables, we have 8. If we had 4 variables, it would be 16 lines. So we'd have 8 and 8, 4 and 4, 2 and 2. But don't worry, in the exam, I'm not going to test you on more than 2 variables. So I want you to know how to do 3 variables, but I'm not going to make you do a lot of this. Okay? So that's how we do it for a proposition. Any questions on that? Okay. So another way that we use truth data is for arguments in order to determine whether an argument is valid or invalid. So what is the definition of a valid deductive argument? Remember we talked about that? A valid deductive argument says, if the premises are true, what does the conclusion have to be? True. So that's a definition. So it's important that you remember that. A valid deductive argument, in a valid deductive argument, if the premises are true, if the premises are true, the conclusion must be true. So we're going to use this information in in order to figure out if a whole argument is valid or invalid. We are going to construct a truth table for an argument and then look to see if there is a condition that true premises lead to a false conclusion. If that's the case, it's going to be invalid. If we cannot find that row which shows that, then it's going to be valid. Okay, so I have an example. Let's do this. Let's say we have this argument. This is premise 1, is if P, then not Q. I'm only going to use 2 variables. P2, premise 2, P and Q. Premise 3 is not P or Q. Therefore, the conclusion is P if and only if Q. Let's say this is our argument that we want to see whether it's valid or invalid. Now remember, the propositions, we only boxed what was the main connector. It was not an argument. But here it's an argument. It's more than one proposition. It's 3 premises and a conclusion. So it's four different propositions. But nonetheless, we're going to do the table exactly like we did the table with the proposition. So we have P and Q. We just list the different premises in a line, just like we did with the regular proposition. And this one, not P or Q, and the conclusion, P if and only if Q. We're just going to do it exactly like we would with the proposition that we just did. And then we're going to fill out the table. By filling out the table, we're considering every possibility for the different propositions as well as the conclusion. And that way, we can look for a row in which true premises lead to a false conclusion. If we find that row, it's going to be invalid. Because in a valid deductive argument, true premises cannot lead to a false conclusion. If we do not find that row, then it's going to be valid. So let's fill it out. Exactly like we did before. True, true, false, false, true, false, true, false. And again, everywhere you see P, put true, true, false, false. Everywhere you see Q, put true, false, true, false. It's probably easier for you on lined paper because you can put it in one row. Okay? So it's more mechanical than anything. You just fill it out. Now you use your knowledge of the rules to fill out the truth table. So here, the negation of Q is going to be what? Very good. False, true, false, true. Now I'm going to apply the rule of the conditional. When is it false? When is a conditional false? When what goes to what?
True.
True to false. So here I have true to false, so it's going to be false. Here I don't. Here I don't. And here I don't. How about P and Q? When is it going to be true? When both are true. So it's true here. It's going to be false everywhere else. Here, which one do I do first? Very good, inside the parentheses. So here I have a disjunction. A disjunction is it's only false if both are false. They're only both false down here. So everywhere else is going to be true. Now what do? I negate it. So the negation of true is false. Negation of true is false. Negation is false. And negation is true. So I'm just filling it in. This one, when is it biconditional true? Both values are the same. So it's the same here, it's the same here. So here. So basically I just filled it out just like I did with the proposition. Now I'm going to look for a row where the main connective in the premises are all true. So the main connectives are in this one, in this one, in this one, and in this one. So I'm going to look to see, is there such a row where those are true and my conclusion is false? Do you see such a row?
Yeah.
So we're looking for the main connector to have what?
True. We're looking for this row. This to be true, this to be true, this to be true, and this to be false. We're looking for that row. Do we have that row? No, we don't. Why? What is this argument?
Invalid.
It's valid, very good. This is valid because the truth table looked at every possible combination and we were not able to find any place where true premises lead to a false conclusion, which means the argument is valid. If I find that row, I have to box that row and say invalid, because I'm showing this is where it's going to be invalid. Okay? Does everyone understand this? So this is constructing a truth table for an argument to determine whether or not that argument is valid. So this is valid. Yes. Okay? Any questions on this?
You put true, the second box, the first premise, second premise, third premise, so basically you're looking at the conclusion. If conclusion is all true, then
No, if the conclusion is false, any place that the conclusion is false and all of these are true, but I didn't find it. There is no row where the conclusion is false. See, the conclusion is false here, right?
yeah.
But this is a false premise. So if there's a false premise, we know how we got to the false conclusion. Remember, deductive arguments, the premises lead to the conclusion 100%. So if the conclusion is false, it must be getting the false from somewhere, right? And if it gets it from somewhere, it could be valid. But if it doesn't, if true premises lead to a false conclusion, that's it. Okay, so one more example of this, and I'll go to the truth shortcut method. Okay, so let's look at this one. The first premise is P1 is if P then Q. Second premise is not P and not Q. Third premise is P if and only if Q. And the conclusion is P or Q. Now that's another example. So we have, again, we put it all out just like we did with the other one. And we write it all in a row. P and Q, not P and not Q, P if and only if Q, P or Q. Okay? So, again, you fill it in. So once you do it a couple of times, it just becomes second nature. You just fill out the truth table. You just do true, true, false, false, true, false, true, false, 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 true, true, false, false, true, false. Okay. Now we fill it in. So the rule of the conditional, only false if, what goes to what?
If constant is false.
That's right, if true goes to false, so it's only false here, otherwise it's true. Now we do the negation here, which is what? Very good. Opposite, false, false, true, true. And we do the negation of Q, so it's going to be false, true, false, true. And then in order to do the conjunction, which values do I look at?
The negation?
The negation is very good. So false and false is going to be false, false and true is going to be false, true and false is going to be false, true and true is true. That's the only way a conjunction is true, is if both of them are true. And here they both have to be what to be true?
The same.
The same. So it's true here, and it's true here, and it's false everywhere. Here it's only false if both are false, which is here, everywhere else it's true. Okay, now I did that. Now I'm going to look at the main connectives. I'm going to look for a row where these main connectives are true and my conclusion is false. Do I have that row? Yes, the last one. This line, I have true, true, false. So there is a condition where true premises lead to a false conclusion, which makes this what? Invalid. So if you do find this row, you're going to box the row. Remember with the proposition, you box the main connected. With this one, you're going to box the row with the argument, then you're going to say invalid. If you don't find anything, you'll just write valid.
So is our test going to be not the same as like the rest? Would actually be doing truth
Yes.
tables instead of
Yes.
like multiplication?
Yes.
I mean, multiple choice.
Now I'm going to ask you, construct a truth table to determine the validity of, or invalidity of this argument. So, any questions on truth tables for arguments? Now, you see how when we had 3 variables, it was like a lot of work, just tedious work to do it. So sometimes we can have a lot more variables. So there is a shortcut or an indirect method to truth tables. So I'm gonna teach you how to do a shortcut method. Remember, we only have these 5 rules, so it's not gonna be that complex. Basically, the indirect method says, now that we know the rules, instead of constructing that whole table in order to be able to figure out which row indicates that it's valid or invalid, instead of doing that entire truth table, what we can do is we can try to see if we can get to that row indirectly from shortcut way. Let me explain that. So let's say we have this. Premise 1 is if A then B. Premise 2 is not A or C. Premise 3 is B. And premise 4 is if A then D. And the conclusion is A then D. So if we're going to do this, A, B, C, D, we would have 4 variables. So we would have a 16-line truth table. It would take us a long time to do it, right? So in this case, what we can do is we can try to look for that row where true premises lead to a false conclusion. In other words, we're going to try and see if we can make it work that this is invalid. We're shooting for invalidity. We're shooting for guilt, not innocence, basically. So what you do is simple. You first start writing them all out, just like we did in a regular truth table. Write down all the variables, which is A, B, C, D, in one row. And then you're going to put the different premises, A to B, not A or C, B, A then D. And then you put the conclusion, which is A. Did I give A then D twice?
Mm-hmm.
The conclusion is D or C. The conclusion is D or C. Okay? So you put this all in one row, and you are going to want to make this invalid. So you're shooting for that row that you want to make it work, that this is true, this is true, this is true, this is true, and this is false. You want to set it up to be invalid and see if you can make it work. If you can make it work without any inconsistencies, then you just found that one row in which this whole argument is invalid. Let's see if we can make it work using our knowledge of the rules. For example, if our conclusion is D or C, we know that D or C is false if what? Very good, if both of them are false. So D has to be false, C has to be false for this whole thing to be false, right? And we know that the variables have to be the same in one row. So we know now that the value for C is false and D is false. And anywhere else we find them, we're going to put false. Everybody follow? So we're trying to make it work. We're trying to use our knowledge of rules to make this all true leading to false and see if we can make it invalid. If we can make it work, it's invalid. If we cannot make it work, then it's going to be valid.
So in terms of doing the shortcut, so whatever your conclusion is, you try to see if it's false.
Yes. You're going to assign, the first step is you write them all out. Second step is assign true to all the premises and false to the conclusion. Third step is try to make it work using the variables. So here, one of our premises was already a variable. So B is true. So I know B is true, so I plug it true everywhere I have it.
How do you know it's true?
Because it's a premise, and we're assigning true to all the premises. Now, let's look at this. If D is false, what does A have to be for this to be true?
True.
If D is false, what's the rule of the conditional?
If the consequent is true.
It has to be what? It has to be false, that's right. Because if it's true, we can't make this be false. This will become false. So the rule of the conditional says, if true goes to false, this will be false. I want to make it true. I'm trying to make it work, that it's invalid. So I have to give A, I have to assign false to A. Does everybody see this? I cannot give A true because then this couldn't be true. So if A is true for this to be true, then A is going to be true everywhere. Here I have the value of all of my variables.
Wait,
Sorry,
but
A has to be
it's
false.
false.
I'm sorry.
A is false.
I'm sorry, false. False, false, false. Sorry.
Ah.
So if it's false, you put the false everywhere. Sorry. So now we have the value of all our variables, and we check and see. So false to true, is that true?
Yeah.
Okay. Now, the negation of A is what? True or false? Is that true? Yes. This is true, and this is false. What did we just prove?
That is invalid.
That it's invalid. Because we just proved, we just found, instead of doing the whole table, we kind of found that one row that we were going to box. We found it. We said, ah, look, this is invalid. Because all true premises led to a false conclusion. Questions? Yes.
So when we get this like as a question, are you gonna already tell us what kind of argument it's gonna be?
I'm going to tell you exactly like this. Take this argument, use the shortcut method, and tell me whether it's valid or not.
Gotcha. Okay.
You're going to put it, you're going to assign the true and false under them.
Gotcha.
So you are gonna like let us know if it's a shortcut or
Yes.
Okay.
I'm going to say either use the complete truth table or use a shortcut method. Okay, now one more example of this. So, premise 1, if B then D. Premise 2, not A or C. Premise 3, A or C. Premise 4, A then B. And the conclusion, B or C. So, let's change it up a little bit. So, again, we put down A, B, C, D. We write all of the premises, and we write the conclusion. So we put the first premise, if B then D. Second premise, not A or C. A or C. If A then B. D or C. So, what do I do? What's the first step? I assign what value to the premises and what value to the conclusion.
True to all premises.
Excellent. Very good. Now remember, when you're assigning true, here I'm giving you simple examples so we can do it. But it could be a long proposition. You're assigning the true to the main connector always. Okay? And then false to the main connector of that. So, again, if we have D or C, what do D and C have to be? False. So we have D and C be false. Now, what can we do? You guys, it's not important where you start. Anyone that gives you 100% response, do that. So you know, for example, here, what does B have to be?
False.
False, because if it's true, this cannot be true, right? So B is false, so I assign B as false here. Now, you can do any one of these actually. So let's look at this one. A or C. For A or C to be true, if C is false, what does A have to be?
True.
True, because if both of them are false, this is going to be bad. So A has to be true, A has to be true, for this to be true, A has to be true. So now let's figure it out. So now, false to false is true, is that okay? Now what's the negation of A? What is false or false? False, but here we wanted it to be true. You see there's a problem. We have a problem. False or false is going to be false. So this is an inconsistency, so I'm going to box it. I was not able to make it work. Even here, look, I said true to false is true, but true to false is false. So whichever one you start with, you box it. The reason you were not able to make this work is because it's valid. If it was invalid, you would have been able to make it work.
Ah.
Oh,
If
does that
it's-
also work with A then B?
That's right.
Because,
Yeah, true to false
Because
equals false. Yeah, this is also an inconsistency. Yes, Sam?
So when we're trying to find if it's valid or invalid, should we always kind of just go about it by saying that it could be invalid, like by putting the T's and then having the conclusion be false?
You are, like I said, you're shooting for invalidity.
Right,
You're trying to find out one or two scenarios where it's invalid. If you find it, if you can make it work, that's it, you don't need the full table. But if you can't make it work, it's because it's valid. It's because there's no way that true premises lead to a false conclusion. That means it's valid.
so can we stop there then, or do you want us to fill out the whole?
No, you can stop as soon as you find an inconsistency and you can box it. So you could have started with this and boxed this and that would
Okay, that's, I thought I, yeah.
That's fine. That's fine. There's no order because it doesn't matter where the inconsistency is. It just shows that it's invalid. That it's valid. You cannot have true premises lead to a false conclusion. Any questions? Okay, so let me just do a quick recap. So we have these 5 rules for compound propositions. We have the rule of negation, which always yields the opposite truth value. We have the rule of conjunction, which says it is only true if both conjuncts are true. We have the rule of disjunction, that is only false if both disjuncts are false. We have the rule of conditional, which is only false if true goes to false, true antecedent to false consequent. And the biconditional, which is only true if both of them are the same. So once we know those, we can use these to construct truth tables. We construct truth tables either for propositions, however many variables we have. We have a way that we start. We start on the far left with the variables, depending on how many lines we have. If we only have 2 variables, always going to be true, true, false, false, true, false, true, false. And then we look at the main connectors. If it's a proposition, we just work through the main connectors and then box the main connector. If it is for arguments, we lay it out in one line, do the truth table, look for a row where all true premises lead to a false conclusion. If we find that row, then we're going to box that row and mark it invalid. If we do not find that row, we don't box anything, we just write valid. And with the shortcut, instead of writing the entire truth table, what we're going to do is just put it all in one line, list all the variables, assign true to all the premises, false to the conclusion, and try to make it work using our knowledge of the rules. If we can make it work, then we have proven that it's invalid. I know it's a little counterintuitive. If it works, it's invalid. But we're shooting for invalidity. We're not shooting for validity. If we cannot make it work, it's because it's valid. We cannot have true premises lead to a false conclusion. And that's how we use truth tables. Questions on truth tables? All right, we're done.